Sketch the graph of the polynomial function. Make sure the graph shows all x-intercepts and exhibits the proper end behavior. All right, so if I'm going to talk about end behavior, I need to know the degree. Well, if I actually distribute this all out, and I actually did x minus 1, you'd get x squared plus blah, 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 who cares? But I know that first one is going to be x squared. So it's going to be x squared plus something. Here it's going to be x cubed plus something. Now if I multiply this by this, you're going to end up getting x to the 5th plus a bunch of stuff. So the degree of this whole thing is going to be x to the 5th. And since 5 is odd, we know that an odd function is either going to look like this, or it's going to look like this. And if you notice, this is positive. It's all going to be positive. There's no negative up front. So it's going to be this one, because as x goes to infinity, this is also going to go to infinity. So in this case, it's going to do this. I know that I'm going to have a 0 at 1. And because it's squared, I know it's going to bounce there. And then I'm going to have a 0 at -2. And that's cubed, so it's actually going to, it's going to do something like this. We're going to go start here. And when I get here, I'm going to actually inflection it. Because if it was not a 3 and it was 1, it would actually go through like this. If it's anything other than 1 and it's odd, it's going to go through like this. Then it's going to go up. Oh, we should probably figure out our y-intercept. If I want a y-intercept, I set x equal to 0. So if I set x equal to 0, we end up getting 0, -1 squared multiplied by 0 plus 2 cubed. That gives me -1 squared multiplied by 2 cubed, which ends up being 1 times 8, which is 8. So my y-intercept is 8, so that means it's going to go up here. So my graph is going to go from here, and it's going to go up this way. And who knows, it might actually go a little higher than 8, we don't know. But then it's going to go through 8, it has to go through 8, then it comes down this way. And then right here at this point, if you notice, this is squared, which means we need to bounce off. So we bounce off, and it goes off to infinity. Now, if you forget end behavior and all that stuff, we can always make a number line. And we put our points of interest, which is going to be -2 and 1. And then you can just plot a bunch of stuff. So if I plot, let's say, -3. If I plug -3 into here, I get -3 minus 1, which is -4. -4 squared is positive. So that's positive. And then I plug a -3 into here. It'll get -3 plus 2, which is -1. -1 cubed is negative. So right here, a positive times a negative is negative. So over here, it's going to be negative, which means it's going to go below the x-axis from here to here. Now, if I plot another one, let's say right here I try 0. I plug 0 into here, I end up getting 0 minus 1, which is negative, squared, so that means this is still going to be positive. And then I'm going to do 0 here. 0 plus 2 is 2. 2 cubed is 8, which is positive. A positive times a positive is going to be positive, so right here it's going to be positive, which means that from -2 to 1, it's all going to be above the x-axis. And then after 1, we're going to plug in, let's say, 2. So if I plug in a 2 right here, I get 2 minus 1, which is positive, 2, which is 1. 1 squared is 1, which is positive. So this will be positive. And then I plug in a 2 here. 2 plus 2 is 4. 4 cubed is positive. So that's positive. Positive times a positive is positive, so this will be positive. Which means that from 1 on, it's going to be above the x-axis too. So that will actually give me that bounce right there. So if you forget, you can always do a number line.